Find the general indefinite integral. And so we have the integral of 2x dx. Which of the graphs shown below, which of the graphs below shows several members of the family? So if we're taking the integral of 2x dx, we're talking about the antiderivative of 2x. And what's that going to be? Well, it's going to be 2x to the second power, because this was 2x to the first power. So we increment the exponent to 2, and then we divide by that newly incremented exponent. So this is going to be x squared. And you might have done that on your own. You said, okay, I know that the derivative of x squared is 2x, so the antiderivative of 2x is x squared. But we aren't quite done yet. Because remember, this isn't the only antiderivative of this. We could add any constant here. If we add some constant here and we take the derivative of it, we still get 2x, because the derivative of a constant with respect to x, it's not changing with respect to x, so its derivative is 0. So the antiderivatives, I guess you could say here, take this form. Take the form of x squared plus c. Now what does that mean visually? So let me draw, I can draw a neater version of that. So slightly better. So if that's my y-axis, and this is my x-axis, we know what y equals x squared looks like. Y equals x squared looks like, just draw the general shape. So y equals x squared looks like this. Now what happens if I add a c? Let's say y is equal to x squared plus 2, when 2 is a valid c. So we could say, so I'm going to write this down. This right over here is y is equal to x squared. But remember, and I guess you could say that in this case, our c is 0. But what if our c was some positive value? So let's say it is y is equal to x squared plus, I don't know, y is equal to x squared plus 5. Well then, we're going to have a y-intercept here at 5. So essentially we're just going to shift up the graph by our constant right over here, which is positive 5. So we shift up by positive 5, and we will get something that looks like this. We just shifted it up. Now you might be saying, okay, well that kind of looks like this choice right over here, but this choice also has some choices that start down here. I thought we're adding a constant, but you remember, this constant can be any constant. It could be a negative value. So in this case, c is 5. In this case, c is 0, but c could also be negative 5. So c could also be negative 5. So if we wanted to do y is equal to x squared plus negative 5, which is really x squared minus 5, then the graph would look like this. It would shift x squared down by 5. So this one is shifted up by 5. This one is shifted down by 5. So you would shift by the constant. If it's a positive constant, you're going up. If it's a negative constant, you are going down. So B is definitely the class of solutions to this indefinite integral. You take any of the functions that are represented by these graphs, you take their derivative, you're going to get 2x. Or another way to think about it, the antiderivative of this, or the indefinite integral of 2x dx is going to be x squared plus c, which would be represented by things that look like, so essentially y equals x squared shifted up or down. So I could keep drawing over and over again.